I need to make an oval iris plate for a microwave antenna. I want the oval to be extremely accurate. It'd be easy on a CNC, but my new one's still being built, so I'm going to make a special fixture to use on my manual lathe and mill. The fixture will have a sliding dovetail to set the offset of the oval so I can hold it in the lathe to bore the circular ends, and then move it to the mill to make the flat sides. I created a model in Fusion 360 and made a 3D print on my Prusa so I could get a proper feel for the dimensions. There's lots of lathe and mill action and metrology to make the fixture, and then I'll use it to make the finished iris plate to match the antenna to a waveguide feed. It still needs to be finished, and then I'll probably try marking it using my new Creality 40-watt laser. More of that in upcoming videos. I'm using some EN8 steel bar. Let's get started. I really must get a better bandsaw one day. Face off. Then I'll machine the mounting spigot. When you get the feeds and speeds right, this steel machines very nicely with good chip formation and a decent finish. The chips make nice C's and 6s and are a good colour, straw to blue. Flipping the workpiece round, the next job's to make the head of the mount. A quick chamfer and that's the turning complete. Those long spiral chips in the facing cut are less than ideal, but so pretty. Next step's making the sliding head from another bit of EN8. I'm using my excellent Edge Technology chuck stop spider to ensure the workpieces are aligned parallel to the chuck. Links in the description. Here's a quick Back to the Future moment. That rather lovely Tesa micrometer came from the DeLorean Motor Company factory. Right, size is good, now for the other end. Let's see how heavy a cutter I can take.
Getting a bit over-enthusiastic, perhaps?
Yeah, the Colchester has a 3 horsepower motor, but that was a bit of an aggressive cut. Another light chamfer to break the sharp edges. I never realised just how useful this simple little tool would be. It comes with a number of mount sizes and a range of precision parallels. I did have to trim the 2.5 inch mount to fit the 2-inch throat of this Pratt Bernard 200mm 3 job, but I just love it. I was a bit nervous about choosing the width of the dovetail and the location of the slit for clamping, so I printed the CAD model on my Prusa to make sure it looked and felt right before attacking the steel. I've got a Bamboo X1 carbon now, so that'll be featuring some upcoming videos. Watch this space. I was going to machine some soft jaws to hold the parts for milling, but in the end I went with lots of parallels and a V-block. This carbide rougher can move plenty of material, but the finish isn't great, so I ran a light cut with a 3-flute slot drill to prepare the slot for the brazed carbide dovetail cutter. Line it up and... oh.
That's the smallest dovetail cutter you have. When the going gets tough, the tough go shopping. Time to hit Amazon Prime.
Welcome to tomorrow. This is a super low-cost dovetail cutter from Amazon. I'm astounded to say it worked extremely well. Links in the description as usual. I really must make a dovetail cutter with a carbide insert one day. Not bad at all, I think it'll do. Right, now for the mount. Similar setup in the vise. I'm using my lovely Haimer 3D tester to check the positioning of the workpieces. First, I do a quick sweep to find the approximate centre of the workpiece and then zero the Haimer and DRO. Now zero on the back face and half the dimension on the DRO. That puts me close to the centre of the body. Same again for the left-right sides, and use the half button on the DRO. Finally, a verification check of the front-back axis, and we're on centre. Once more, I'm using that carbide rougher to hog out the majority of the waste. I'm running this too aggressively, the chips are almost black at times. Right, I'll just spin the workpiece round and align it to the transverse axis.
Excuse me for asking, but why didn't you just cut front to back, or cut the dovetail side to side?
That's one of the mysteries of the universe, Amy. We may never know. OK, I'll come clean. I had to do another job in that vise, and seeing as I had to realign and recenter everything, I decided to do it front to back, as the vise might hold it more firmly in that plane. Look, that's my excuse and I'm sticking to it, right? Right. OK, time to recenter in the usual way, so I'll whiz to the back and front, remembering to go past 0 on the back to avoid backlash, and then wind back and... Whee! Oh dear, the joyous sound of burning money. Luckily, I had a horribly expensive spare probe tip. That ceramic's designed to snap when an idiot does something stupid. Amy, was that you smirking? The machining went fine with that ludicrously cheap dovetail cutter. Quick trim and deburr and test, and it fits beautifully. Now to machine the flat so I can hold it in the vise, and we're done. The slot for the clamping screws needs to be parallel to the dovetail, so I checked it with a round bar. I could have used slip gauges, but that bar was exactly the right size. The slitting saw worked nicely, although I was a bit nervous about cutting too deep and ended up a little too shallow. I should trust my instruments, not my instincts. I drilled the holes for the set screws with a stub drill and used an end mill in a chuck as a sort of spot face afterthought. Look, don't at me, bro, I've no idea what I was thinking. tapped the holes with a spiral flute machine tap, then ran a modified plug tap with the end ground off to finish the threads, using a slip of paper to tell when I'd reached the bottom of the hole. My cunning plan about using set screws fell apart when I found I hadn't got any of the right size, but also because the slot was a tad too shallow, I needed a lot of torque to tighten the clamp and ended up using plain high tensile cap screws. I might fix that for the next job, but for now, it'll do. Next job's to bore out the centre of the fixture for clearance behind the workpiece. I adjusted the slide to get the body exactly on the lathe axis, then drilled and bored a shallow relief. Then I drilled and reamed an 8mm centre hole for alignment. Back on the mill, I centred the fixture and milled 2 flats. To check how good my centering is, let's put an 8mm gauge pin in the chuck and see if it fits the hole. See, Amy, I'm not totally useless. This 6mm spotting drill will do nicely for starting the 4 threaded holes in the fixture. Now I need to use the DRO to make a pitch circle offset by 22.5 degrees for the 4 alignment pinholes. I'm using a 3mm spotting drill for the dowel pinholes. The dowels are a 1/16 of an inch. I'm drilling the holes using a 1.6mm metric stub drill, as it makes a very good fit without having to use an expensive tiny reamer. Right, moment of truth. Will it fit? It actually made a tiny pop, honestly. It's time to drill the mounting holes ready for tapping. I'm using a 3.2mm HSSE split point drill. For a change, I'm going to use my lovely Vertex tapping attachment to make the blind threaded holes using a Spiral Flute M4 tap. That's the fixture completed. It's a bit tricky measuring the holes with a 3-point bore mic because part of the circumference is missing. I should really make a go-no-go gauge. That's the two ends completed. Now I need to machine the flats. The whole fixture moves over to the mill with the correct alignment. I don't really need to check both holes again, but I wanted to ensure that the axis was properly aligned and that the centre line was perfect. After that, it's just a question of assuming the OD of the cutter's accurate and cutting a fraction less on the width, then checking the exact width with gauge blocks. Just in case you're unaware of gauge blocks, they're highly precisely lapped to a fine mirror finish which allows the surfaces to ring together and adhere as they're so flat. You may know them as Joe blocks after Johansson, the manufacturer. Mine are precise to a few tens of nanometers, but you have to allow for temperature and also the tiny boundary layer between the blocks. I only care to within maybe 5 micrometers for this application. Well, definitely not a perfect job because I made one of the holes a few micrometers too large, but for a first attempt, it'll do. The next one's going to be perfect. The completed horn just needs finishing to size. That'll be in another video. Huge thanks to my Patreon supporters, subscribers and audience. I've got loads more material in the pipeline. In the meantime, you might want to watch one of these.